Okay, guys, so I know that you guys can all simplify square roots already, but higher order, meaning that technically we can have a third root or a fourth root and so on and so on. This thing right here, what do we call this symbol? A radical sign. Okay, so that's what we're going to spell out, radical sign. And then the thing that's under the radical sign is called a radicand. So if I say, oh, the radicand 64, that means the number that goes under. Now, the small number that goes in between that little angle pocket, anybody know what that is called? It starts with an I. An index. I heard someone saying it up front, okay? So start an index. So if I say, oh, the index is 3, meaning that it's a third root. If the index is 5, and then it's a fifth root, and so on and so on. Well, guys, if you don't see an index at all, what root is it? Square. Okay, all right. There are 2 methods. We're going to read the guidelines here. Sean, method number 1, read all 5, please.
Rewrite using exponents, simplify anything you can, anything less statement.
Great. And then Jacob, method number 2, bud. Read all 3 steps.
Factor using squares,
Perfect. Okay, here we go. Examples 1 to 3. We're going to find the index first. Simple, all right? Example 1, what is the index? We don't need to simplify, but Kayla, what is the index for example number 1? 3, yeah, look at that. Nice and simple. Jackson, example 2, what is the index?
5.
Yep, okay. Roman, example 3, what's the index?
1.
Is it 1? If it's not there ever, we are going to say that it's always a square root. And the square root index is 2.
My random brain thought it was a simplification.
Nope. We're going to simplify right now, buddy. 4 to 16. Simplify each rational expression. Okay? So, let's see. What is the index for number 4? 2. Okay, so this is the part where the index matters. If the index is 2, how many identical numbers or variables would you need to simplify it outside of the square root sign or the radical sign? 2. If the index is 3, then you would need how many identical? 3. If the index is 5, then you need how many? 5. Exactly, that's why the index is important. Okay, 50. You can do multiple ways. You can find out the perfect square number straight up. What is the perfect square number for 50? 50. Is there a perfect, oh, when I say perfect square, give me a perfect square number. 4. Why is 4 a perfect square? 2 times 2, another one. 25, why 25? Great, another one. 36, why 36? 6 times 6, another one.
64.
64 because? 49 because? One more. 81. How about 1? Yeah, those are all perfect squares, and it can go further. So students, 50, there is a perfect square. It's 25 times what? 2. So if you know how to get there straight up, then get there. Well, what's square root? Okay, when you have the square root, y'all, when it's a multiplication under one big radical, we can break them up into multiplications of multiple radicals. What's square root of 25? 5. Can I do anything square root of 2? No. So we multiply back down, and this is our answer. Now, if you can't get there, then do prime factor tree. 50, it's all for these 10 times what? 5. 10 is what times what? 2 times 5 or 5 times 2. How many 5s do we have? 2. We write them all in. So we say, okay, there are 2 5s and then 1 2. And then this is a couple. That means it's a square root, so we can take 1 out, right, y'all? Answer the same or different? Same. All right. 108. If you know a perfect cube, then straight up do it. But if you don't, then do prime what? All right, 108, I know it's even. 2 goes in there how many times? 54. Even again. 2 goes in there how many times? Ooh, 27. It's a perfect cube, but if you don't know, it's 3 times what? And 9 is what times what? Look at that. Now, these are all the prime numbers. And I'm going to write, okay, it's a cube root. How many 3s do we have? 3. So we write it 3 times 3 times 3. How many 2s? All right. Do we have 3 of the same number? Yeah, that means we can be simplified out. Okay, cube root of what inside? Of what? Inside. Nope. Remember, 3 must be taken out. 4. Okay, remember, it's a cube root. So, say that one time. It's a cube root, y'all. That means we need 3 identical what? Number, right? Or variables? Do we have 3 identical 3s? Yeah, so that has to be taken out of the house. It's no longer grounded. Okay?
No longer.
No longer. The 2s, we only have 2. So it is still grounded, and it has to stay inside the house. Bro. All right, you try 64. I'm sorry, no, 64, 24. Once you have an answer, I want you to box it up. All right, the closest birthday to January 1st, share first. Once you have an answer. Figure out whose birthday is closest to January 1st. So in your group, figure out whose closest birthday to January 1st and share that, please. Work out number 6. All right, whose closest birthday to January 1st? You are? What's your final answer? 2 square root 6. Okay. Whose closest birthday to January 1st?
Her birthday's tomorrow.
Whoa! So who's the closest? Her? Oh, Lucy. What's your final answer to number 6? Share it once you have it. All right, Susie's team. Whose birthday is closest to January 1st? Susie's team. You're not Susie. Susie's team. Whose birthday is closest to January 1st? Okay, what's your final answer? What is it? 2 rad 6. Kayla's team. Do you agree?
Yes, I agree.
All right. 7 on your own. Work it out.
Oh, I already won.
Yeah, because 6 is 2 times 3. None of those are perfect, right?
Oh, it has to be a perfect.
It has to be the identical for you to take it out of the house.
Oh, wait, there are 4.
Okay. Now, guys, number 7. How many identical numbers? 4. You need 4 identical. Okay. All right. I want the tallest person to share now. In your group, the tallest person.
Just need to make sure.
Hey, Carter, who is the tallest person in your group? You are, buddy. Okay, what's your final answer?
2 rad 5.
2, what index, Carter? 4. You have to make sure the index is written back. Okay, Andrew, who's the tallest in your group? You? What's your final answer?
I got 4 rad 5.
4 about 5. Okay. Did you have fourth root still written in there? Okay. Okay. Shh. Calvin, who's the tallest in your group? You. What's your final answer for number 7?
I got 2 rad with an index of 1 and 5.
Beautiful. All right. Here are some different answers. Obviously, 2 of them are the same. 80, y'all. Did you guys factor it down? Okay. I know it's 2 times 40, right, guys? 40 is 2 times what? 20. 20 is 2 times what? So I got those primed already. And then 10 is what? All right. So how many 2's do we have? 4 2's. So students, if we have an index of 4 and we have 4 2's, okay, we can take it out of the radical house. Okay. So final answer 2. 4th root of what? 5. All right. Okay. Shh. What happens if there is a negative in the front? Guys, if there's a negative in the front, it is exactly the same as saying that this is hold on. Thank you. If there's a negative 1 in the front, guy, it's similar to saying there's a negative 1 times square root of 64. We should know 64 is a perfect square number. Square root of 64 is? Negative 1 times 8 is? Negative 8. Box it up. Okay. What happens if there's a plus or minus in the front? It's the same as saying there's a plus 1 and a minus 1. We're just saying that, hey, y'all, there are 2 answers coming. Okay, that's all that is. Okay. This is the part where I do need you guys to pay attention. What is the square root of 81? 9. So there should be a plus or minus 9, right, guys? N square should be n times what? N. What's your index? 2. So can I simplify n squared? For sure. So this one, I'm going to write it down for you. Okay. This is say, hey, 9 times 9, n times n. Both of them are identical. So we can take it out and write plus or minus 9 what? N. Okay. All right. If there is a negative in the front, then we're just going to carry that down. If there's a plus or minus in the front, we're telling you, hey, there are 2 answers coming. So we are going to end up with 2 answers. All right. Now, this is the part where let's talk about square roots. Anything under the radical for a square root, can it be negative ever? No, right? Except, can you guys see that all this is not negative inside? Can you guys see this? But there's negative 1 being multiplied to the final answer. That's why our answer is negative. Similarly to this, it is a square root. Technically, whatever's under here can never ever be. But there's a negative and positive out front. That's why our final answer has those. Would you guys agree that this right here, again, is a square root? Okay, this is the part where it's super confusing. Whatever comes out of it, there's not a negative being multiplied. Would you guys agree? So your final answer must always be positive. Well, let's talk about this. N plus 1 to the 4th. How many of those do we have? There's 4 of them. What's your index? 2. I mean, we can take out how many? We can take out 2. You're right. So, we can take out 2. And this is what it's saying here in the arrow. If you don't have it written in, fill it in, please. If we can take out 2, would you agree that's the way that we write of taking out 2? And it says here, well, technically, if your index is 2, and we have a power of 4, it says here, divide your exponent by what? 2, since that is the index. Okay.
Is this supposed to be x?
X, sure. Thank you for correcting me. All right. Let's go back to this one then. What is the exponent here? What's your index here? Right? So would you agree that's why we have an n here? So now, n plus 1 to the second power. Anything that's, remember x is unknown. Sorry, not n, x plus 1 to the second power. Will that answer be negative ever? Because square, anything square will always be what? Positive, okay? Because we're going to get to the part where we might need to do something special soon. All right, the first 10 examples. Nothing new, right? If we don't know perfect cubes, we don't know perfect squares, we can always factor down to what? What kind of numbers? Prime numbers, all right? Okay. 11. What is the index? 3. It's 8, a perfect cube, y'all. Yeah, sorry, I need to find my examples. I lost it. We're on 5. All right. Now, what is the index? 3. So you can go straight to. And remember, when you have a multiplication, students, and it's under one big radical, we can separate them and rewrite them as a multiplication of the same index, right? What's cube root of 8? 2. Can we take the cube of n squared? No, why not? Because how many n's do we have?
2.
But we need how many? 3. So it stays inside the radical house. But this could be simplified down to 2. All right. Now, cube root. Can we have negative numbers under the cube root? Like, what's cube root of negative 8? Okay, here we go. Yeah, negative 8. Would you guys agree that cube root of negative 8 is the same as negative 2 times negative 2 times negative 2? Yeah. And because it's cube root, would you agree that we can have it as negative 2 here?
Just not under a square root?
Not under the square root, not under the fourth root, not under the sixth root. So what's the theme? Odd indexes, we can have negative numbers under the radical sign. Even indexes, can we have negative numbers ever? No, okay? So, this is an odd index. Anything that comes out of here, it's a fair game. Does that make sense so far? I'm going to hold it right here. Odd indexes, can we have negative answers? Odd index, yeah, positive and negative, all goes. Even index, so think back to your basic algebra. Can we have a square root that is negative under the radical sign? No, so that's what's happening. So let's try this one. Even or odd index of 12? Odd. So I don't have to worry about the answer. Would you guys agree? What comes out is going to come out. Yeah. All right, let's check this out. We have cube root of negative 125 times cube root of a to the third. All right, let's try a to the ninth. I just give you the answer. I shouldn't have done that. Okay. Is negative 125 a perfect cube? Yeah. What is the answer? Negative 5. It's a to the ninth, a perfect cube. Yeah. What is it? A to the third. Multiplied together, it's negative 5a to the third. It's an odd index, so can I have negative answers? Yeah. Okay, when we get to an even index, and that's what we have to be careful. All right. Uh-oh. Index, even or odd. So that means, your radicand cannot be negative. Would you guys agree? What is the radicand here? No. The radicand is what? X squared. Okay. I want you to really think. Whatever number we square, y'all, is it ever going to be negative? Ever. A number that's squared, like negative 4. Quantity negative 4 squared is what? It's never going to be negative under. But here's the problem. We have a variable. right? The reason we use variable is because we don't know what's going to happen. Would you guys agree? The variable can be positive. The variable can be negative. So we do know the answer is x. True or false so far? Right? Index is 2, x squared. There's 2 of those. Simplify it out. But since it is a variable, and we know whatever comes out of an even index must always be what? Positive. In math, what symbol do we use to ensure the answer will always be positive? You're right. Okay. We must use an absolute value to say, hey, dude, this answer cannot ever be negative. So an IE. All right. If x is -4, okay, students, if x is -4, -4 quantity square, what would that give us? Hold on, so square it for me. What's -4 square? 16. All right, y'all, look at this basic math. But student, square root of 16 is straight up what? 4. But we said x was what? -4. But if you go and put an absolute value around this, is it now positive 4? Yes or no? Yeah, and that's what's happening, okay? Because we can't with an even index. We have to be cautious with the variables. Is that understood? All right. 14. Index is what? Even or odd? Even. N to the 4th. Can we simplify that at all? Yes. What is the answer? M. Except we cannot have a negative answer when we have an even index. So we have to go and do what? Put in absolute value to make sure that this is never ever going to be negative. 15, index, what is it? 4, even index, right guys? So we need to start thinking cautiously straight up. All right. 4th index of a to the 4th. What's the final answer? A, right? Times. We will do all of that in a little bit. 4th index of n to the 8th. N square. All right. I want you to hold it tight. Which one of these might be negative sometimes?
A.
Why A and why not n square?
I don't know. It's like
Because if n squared was negative, it just multiplies it.
Yeah, guys, even if n square is negative, right? If n is negative, anything squared will always be what? But if a is negative, is this possibility of making this positive if there's not a square or 4th power? No. So guys, we only need an absolute value around one variable this time. It's just what? A. So we don't need it for all of them. We need it now for just A. Okay. All right. Index. Oh, come on. I lost my spot again. Index is what on example 16? Not 5. Do we need to worry at all when it is an odd index? No. So you do that one normally. Okay? So you can take a deep breath, be like, oh, odd indexes. I love you. Okay? Because I don't have to worry. Oh, okay, let's tell Alexa to stop.
Alexa, stop.
Okay, that's my key stuff. Okay. 32. Is that a perfect 5th power? Yeah. 5th root of 32 is? 2. 5th root of 5, x to the 5th is? X. 5th root of y to the 10th is? Y what? Square. Do we need to worry about absolute value on odds? No. And we're going to box it up. All right, I'm going to stop right here. You guys have enough to finish your homework tonight, which is what? Yeah, you know what? I'm gonna do you a favor. Do the odd questions only. Tonight's homework is 4.5 worksheet. What?